A warm welcome to my presentation from the fastener and welding design automatically to the simulation model. Automatically means not that we will talk about automation. We will talk about a seamless overgoing of the fastener and welding design to the simulation of an FAM model. Therefore, we implemented a lot of automation in the software. Early and robust connections will lay the foundation for innovation. Then earlier we know about the concepts and we discussed the concepts of connections. Then earlier we can synchronize the work on objects that will be connected together. To work on the objects, a robust knowledge about the connections will help enormous, because all the different systems which will be connected together, or objects that will be connected together, know or will base in the connection knowledge on the same foundation. And this knowledge and documentation will be helpful to streamline the transition to detailed design. This is not coming from my side, this is coming from Dr. Klaus Hoffmann. He is a senior system engineer with a lot of experience and knowledge that there's an area where a lot of failing can appear. We will review or discuss this topic in 4 chapters. In the first chapter we will have a look on the design of fasteners and welds, and afterwards in the second chapter we will idealize the design for finite element model simulation. In a third chapter we will create meshes of the representative volume and shell or mid-surfaces geometries. And then in the fourth chapter we will create meshes that represents the fastener and welds, whereby the fastener and welds was designed in the first chapter, and we reuse this knowledge from there. You can have a look in all the 4 chapters and review these data. I will directly spring to the end after the 4 chapters and have now a little bit a discussion about the benefits of an early seamless connection integration in the workflow. One of the benefits is early connection implementation, and that will reduce the rework. So establish connections in an early phase helps to identify issues sooner. And sooner knowledge about issues will cut rework, especially if the rework appears in a late phase of the development process. The Boston Consulting Group is talking about 20 to 25% of reduction. Another benefit is the seamless transition to detailed design. So a robust connection framework, so documenting the connection in an early phase, will smoother the design phase. There's not so many different ideas followed down parallelly, and this will reduce the cycle times. A Siemens internal research figured out a number of 10 to 15% of reduction of the invests over there. And another benefit is an immediate visual verification. With such an visual verification and an early visual verification, we can enhance the quality of the design. So early visual checks boosts the defect detection. The Deloitte Insights organization is talking about a reduction of 10 to 15%. And this will a warm welcome to the presentation from the fastener and weld design automatically to the simulation model. Actually, we're in the first part, the design model, and there we can see a CAD model of a design study where we can implement reduced but efficient screw connections. Different kind of screw connections will be possible. For our first example, screw connections as fasteners with a bolt and a nut set where objects will be tied together, or a second and third example can be a drill screw that can be drilled in a thread that passes fully through or partly through an object and will be tied with the screw to an object with a hole. Actually, we're creating such an example of a fastener screw where we have possibilities to detail and add objects such as heads or other things. Also, weldings can be adapted to the design. Thereby, weldings can be also different in the type. For example, welding connections or connecting objects dependent to connection curves are possible, as well as weldings based on faces that will be welded together. To have a more easily check of weldings and also of screws, we can select using a filter or manually, such as here, the connection features and set the objects to a transparent representation style. This will help to identify areas where connections will miss or will different. Here is, for example, the second example how weldings could be realized. Here in this example, the welding will be realized by two facing sets or face sets, and one face set will be connected afterwards to the second face set. And there is also the possibility to define more details in the feature. In sum, NX and Designcenter 3D provides possibilities to easily and early create connections, detail these connections afterwards, and make it easier to visually check the connections. A warm welcome to from the fastener and welding design automatically to the simulation model part 2. Now we will idealize the design for meshing. Here we will make the design ideal for meshing. Therefore, we create an idealized part dependent and associative to the original design part. Nevertheless, we will edit some design parts, but the original design study should be kept. Therefore, the idealized part and the promote function are used. the material thickness of the table frame is thin. A more ideal representation of thin shells in the simulation will be based on mid-surfaces. To realize this, we are using the mid-surface feature. And afterwards, we can check the model, such as in the video previously, using the see-through function to control the results of our work we have done. During our work, we benefit from the possibility to keep the trained user interface feeling and have an easy cleaning and adopting of CAD data and initializing it. Thereby, we kept the design study data safe. A warm welcome from the Fastener Welding design automatically to the simulation model, part 3. Here we will create the mesh including the finite elements. First, we use the standard 3D tetrahedral mesh feature for volume meshing. Multiple objects are represented as volumes. Not only the table plate, also parts of the frame will be represented as volumes. Other parts of the frame will be represented as mid-surfaces. For meshing the mid-surfaces, we will use the 2D mesh feature. This will be shown later in the video. The used volume and mid-surface approach can be realized easier. But I will show that handling combined approaches will be possible within our software. The flash behind the mesh size will recommend a maximum mesh size, ideal as a maximum for the object. As summary, we can say that we have strong capabilities of data handling, blending in, blending out, and strong volume meshing capabilities as well as strong shell meshing capabilities, also strong capabilities of 1D and 0D meshes. A warm welcome from the Fastener Welding design automatically to the simulation model part 3, and this will be an additional to the part 3. We created the volume and shell meshes yet previously in the part 3. Now we will add the bolts and welds and create the connection meshes and elements as well as spiders, what will be 1D meshes. Thus, we will add the bolts and ongoing create connecting elements presenting the bolts. Thereby, it is possible to select different approaches how to create the connecting elements and spiders. So in the end, the 1D elements. Nevertheless, creating of the bolts take time because they have to be selected individually. We can overtake a lot of information from the design model, but there will be a lot of bolts. I will undo the yet done FM work on bolts, because I will show how to execute a self-written script that will identify, select, and create the bolt connections for you and the user. And thereby, the script will select all bolts that will be included in the design model done previously in part 1. In case of the weldings where a much higher number of weldings exists, the manual work invest will be high, much higher than in the case of bolts, because we have much more weldings. But I have also written a script similar to the bolt solution. And this script will do the work for you and for the users as well. So means it will identify, select, and create the weld connections. Afterwards, we define the connecting elements creation approach for bolts as well for weldings, and create the connecting elements and spiders, mostly realized as 1D elements. Thus, as a result, we got the bolts and welds we have previously defined in the design model, now in the FEM model, and we have not to do the meshing manually. It will be done automatically, independent if you do it as a manual load of the bolts and welds or with the scripts. Thus, a summary, we can say that this will reduce invest through knowledge reuse of the earlier definitions of welds and bolts. We have an automated creation of bolts and weld connections, what will fastener, and acceleration through the automation scripts will be possible. And acceleration and quality improvements in the FEM model creation process was achieved.